So the answer for this question is A, 1. What are the solutions of 1 is equal to 2 divided by x squared plus 2 over x? So what you're going to do is multiply both sides by x squared, and then this cancels out here. Then we have x squared is equal to 2 plus 2x. Then we have x squared minus 2x minus 2 is equal to 0. Now this is an unfactorable expression, so then we have to use the quadratic formula, which is equal to x is equal to 2 plus or minus 4 plus 8. And now we just divide this by 2, and then we have 2 plus or minus the square root of 12 over 2, and then x is just going to equal to 1 plus or minus the root of 3. And this we can see is this expression right here, so this is C. Which of the following tables could represent an exponential function? So let's analyze what's going on in each of these. So what we can see here is that the ratios are changing, which is not a characteristic of exponential functions. Here we can see that they are negative, and then they're positive, and then there's just no general pattern. Not quite. So we can say that this is inconsistent, and this is not the answer. Now let's examine C. So what we can see is that for the outputs, we can see that we have equal length intervals for all of the input values, and for the output values, we can see that they are all being multiplied by 4 each time, so there is a constant ratio, and they're being scaled by a multiplicative factor. Now we know this is probably our answer. We can check D just in case. So now we can see that there's no pattern apparent here, so that makes our answer just equal to C. Now 11, let f of x equal to a times b to the power of x is greater than 0. Then f of x plus h divided by f of x is going to equal to what? So we can rewrite this using what we know. So we know that a times b x plus h is equal to divided by a times b to the x, and this would just be equal to b to the h. So that is just going to be A. Use the property of logarithms to determine which of the following is largest. So that's on this page. Which of these is the largest? Now, what we will do is we have to start by evaluating each of these. So in order to evaluate 2 ln of 4, you're asking what is the base and what is the thing that multiplies to that. What can you raise to the power of that to get that expression? So how can we rewrite ln of 30? And how can we rewrite ln of 2? Well, we can use the fact that they're both ln, so we can use this ln 30 over 2, and that's just going to be equal to ln of 15. Now for b, we can have 2 ln of 4. That's going to be equal to, we can raise that 2 up here, which is a property of logs. So then this becomes ln 4 squared, and that's going to be equal to ln 16. So we're all trying to get these into a common format so we can easily compare them. So we have ln 3 plus ln 4, so this is going to essentially be ln 12, and that's because they're both ln, so you can just add the contents of what these things are. So now ln 4 over ln 2, we can just rewrite this as log 2 4 is equal to 2. Now, computing these numerical values, we can estimate that this is 2.7, 2.77, 2.48, and this is 2. So that means the largest is B. So this is B. Now we have some FRQs. Graph the following rational function f of x and find the following. The domain, the x-intercepts. Okay, let's see here. Oh, but let's do 13 first. So let's say we have log e minus log 2 e divided by 16, and that's going to be equal to log 2 e divided by e over 16, and that's going to be equal to log 2 times 16. So this is just equal to 4, because 4 squared is equal to 16. So now we're going to analyze this rational function. So we can just do this by adding another page. Then we'll change the template to something else. Okay. So we have the function f of x is equal to x squared minus 4 divided by x squared minus x minus 2. So how are we going to tackle this? Well, we have to start by factoring. So we get x minus 2, x plus 2, and then we get x minus 2, x plus 1. And then we can cancel out the common factor of x minus 2. We're left with f of x is equal to x plus 2, x plus 1, and we know that x cannot equal to 2. So for our domain, we're gonna exclude the zeros of the original denominator. So x cannot equal to negative 1 or 2. So then for our domain in interval notation, we can write this. Negative 1, union, negative 1, 2, union 2, infinity. So now we can identify the intercepts. So the x-intercepts, we're going to have x plus 2 is equal to 0, which is the factor in the numerator. And then we set that equal to 0, and this is 1. And then we have x is equal to negative 2. For our y-intercept, we have f of 0 is equal to 2 over 1 is equal to 2. So then we have 0, 2 as the coordinate point and negative 2, 0. So now we have to find the vertical asymptote. So we have x is equal to negative 1, and we want to approach this from both sides. So we have a limit x approaches negative 1 from the negative side, and then we have f of function f of x, and then we have this function is going to equal to negative infinity. Now we have a limit x approaches negative 1 from the positive side, and then we have f of x is equal to positive infinity. So now our end behavior using limits, we know that the degrees are equal. So therefore we know that the horizontal asymptote is going to be y equals 1, and we know that a limit of x approaching positive or negative infinity of f of x will equal to 1. Now the hole that we canceled earlier from here, to get this hole, then we have to plug in the value into the function that we have left over. So that's our leftover function. And we need to plug in this x equals 2 into the leftover, or simplified. So then we have y is equal to 2 plus 2 divided by 2 plus 1 is equal to 4 over 3. So the hole is going to be located at 2, 4 over 3. So now we want to also determine when is this function increasing and decreasing. So when is this function increasing? Well, we know f prime of x is going to equal to x plus 1 minus x plus 2 divided by x plus 1 squared. And that's going to equal to negative 1 over x plus 1 squared. That's going to be less than 0. So it's always going to be negative. Therefore, the first derivative is decreasing, everywhere in the domain. So that means it's decreasing on all domain intervals. So now we can determine the concavity. So in order to determine the concavity, you have to determine the second derivative. So you have 2 over x plus 1 cubed. And we know that it's going to be concave down on negative infinity to negative 1. And we also know that it's going to be concave up on negative 1 to infinity. Now we can move on to question 15. So this is going to be, let's find the partial fraction decomposition of all 3 of these. So let's start off with 15a. Let's say we have 16 over x times x minus 4, and that's going to equal to a over x plus b over x minus 4. So now this is going to equal to 6 is equal to a times x minus 4 plus b over x. And how do we get this? Well, essentially you multiply this by each of the factors. So you will multiply it by x, and you also multiply it by x plus 4. The reason being because we want to cancel these x's out, and we also want to cancel these x's out. And then what is left over, you still have to distribute these to each of the terms. So that means x plus 4 is going to be distributed to this because it's not going to be canceled out because it doesn't have a common factor in the numerator and denominator. And then this is going to be distributed here, and then that's going to have nothing. So now if we set x, we can look at this and think, what can we do? Usually what you always want to do for partial fraction decomp, you look at what would make x equal to 0 because you want to get it to cancel out, and you just want to be left with isolating just one variable. So usually you get the strategy of just doing x is equal to 0, but usually there's a better option for that because both of the fractions cannot be equal to 0. So at x is equal to 0, we have a is equal to negative 3 over 2. And the work for this is going to be that you're going to have 6 is equal to a times 0 minus 4 plus b times 0. Therefore, anything times 0 cancels out. And then from that, you get negative 4a. That's equal to 6. Then you can divide both sides by 6. And then you get negative... Okay. I'll make some room so you can see. Get the 6 out of here. It's better if we just do it like that. Or that's negative 4. Negative 6 over 4 simplifies to negative 3 over 2, and then it's just a on that side. Okay, now we can do x is equal to 4. Then we get b is equal to 3 over 2. So now let's do our next problem. Let's say we have 3x is divided by x plus 2 squared times x minus 4. That's equal to a over x plus 2 plus b over x plus 2 squared plus c over x minus 4. So we want to solve the system. Now, what you're going to do is multiply everything by these factors. So in doing this, then that becomes 4. Then this cancels out with this cancels out with this, and this cancels out with this, and this cancel, yeah. And now solving this, we would get, I want to show all the steps for this. So we're going to have 3x is equal to, this is going to be equal to a times x plus 2, x minus 4, plus b times x minus 4, plus c times x plus 2 squared. Now, oh, you actually don't want to multiply it by that. You just want to multiply it by these. How did I realize that's a mistake? So now we want to expand each term. We can start by foiling these first. So then you get a times x squared minus 2x minus 8. And then you get b. You foil this, and you foil this. That's squared. So you get bx minus 4. Minus 4b. And then you get c times x squared plus 4x plus 4. Now we can combine. So this is going to be 3x is equal to this entire expression. Minus 4b. Three x is going to be equal to a plus c times x squared plus negative 2a plus b plus 4ac times x plus negative 8a minus 4b plus a 4c. Now, what we're gonna do, this is basically a shortcut of combining like factors. So anything you see that's like multiplied by x, you just combine that. And if it's just multiplied by that, that's just alone. So now we can move on to match the coefficients. How do we do this? So the left is going to be equal to 0x squared plus 3x plus 0. And then we get system. It's the left. A plus c is equal to 0. Negative 2a plus b plus 4c is equal to 3. Negative 8a minus 4b plus 4c is equal to 0. Now we have to solve this. So this is a little bit big. So from equation 1, we have c is equal to negative a. Sub into equation 2. So then you have negative 2a plus b plus 4 times negative a is equal to 3. That's equal to negative 6a plus b is equal to 3. And then b is equal to 3 plus 6a. Now sub b and c into equation 3. So now you have negative 8a minus 4 times 3 plus 6a plus 4 times negative a is equal to 0. Negative 8a minus 12 minus 24a minus 4a is equal to 0. Negative 36a minus 12 is equal to 0. And a is equal to negative 1/2. Then we have c is equal to negative a, which is equal to 1/2. And we also have b, which is equal to 3 plus 6 times negative 1/2. And this is going to be equal to 3 minus 3, which is equal to 0. Therefore, we have a is equal to 1/2, b is equal to 1, and c is equal to negative 1/2. Now, we can rewrite our final answer for this partial fraction decomposition as 1 over 2 times x plus 2 plus 1 over x plus 2 squared minus 1 over 2x minus 4. So now we can move on to another problem. This was just one problem. Now, okay, how can we move this over here? And there, you can look at that in all of its glory. So let's say that we have the problem 15c, 4x over. 2x squared plus 3x minus 2. Start by factoring this. So we're gonna have x squared plus 3x minus 4. What multiplies to negative 4 but adds up to 3? So that is going to be positive 4 and negative 1. So after this, now divide that by 2. So it's going to simplify to x plus 2, and then I just move that there, 2x minus 1. So now we can set up the decomposition of, these are our factors, so we can set up our linear factors underneath. A over 2x minus 1 plus b over x plus 2. Now we can multiply both sides by 2x plus 1 and also x plus 2. So now after this, we have to distribute these to everything. And also this as well, you have to distribute this. And then things will cancel out respectively. So then we get 4x is going to be equal to a times x plus 2 plus b times 2x minus 1. And then expanding this, then we get 4x is going to equal to ax plus 2a plus 2bx minus b. Then you get 4x is equal. Now we want to combine the like things. So we'll use orange for linear, and then these for constant. So we have 4x is going to be equal to a plus 2bx, factor that out, plus 2a minus b. And then now we want to match coefficients in a linear system. So now we have a 2a plus 2b minus b equals 4 equals 0. Now from equation 2, we have that b is equal to 2a. Sub into equation 1, then we have a plus 2 times 2a is equal to 4. So it's going to be 5a is equal to 4. Therefore, a is going to equal to 1. Therefore, b is going to equal to 2. So your final answer is going to be 1 over 2x minus 1 plus 2 over x plus 2. Okay. The junior class would like to organize a school dance as a fundraiser. A hall that the class wants to rent costs $3,000 plus an additional charge of $15 per person. Write an inequality to determine how many people need to attend to keep the dance at a cost of under $10 per person. So, okay, how do I want to tackle this? Let x equal to the number of people. A, no DJ. So we're gonna have 300 plus 5x over x is less than 10. So then we're gonna have 3,000 plus 5x is less than 10. X is gonna be greater than 600. B, with the DJ. Well, you're gonna have 4,000 plus 5x divided by x is less than 10. X is gonna be greater than 800. Now we want to do these. Solve these for x. Okay. So 0.031 is equal to 8. So then we have 1.031 to the power of x. That's going to be equal to 8 over 5, right? So then you're going to have x is equal to ln 8 over 5. divided by ln 1.031. Now, let's say we have log 1 minus x minus log 1 plus x is equal to 2. Then you have log 1 minus x 1 plus x is equal to 2. 1 minus x 1 plus x. Now you have to raise both sides to the base. You have to reverse taking the base 10, log base 10 of both sides. So that's going to make 2 into 100. So that's going to be x is equal to negative 99 over 101. So now let's say that we have 7.8 ex over 3 ln 5 is equal to 14. Ex over 3 ln 5 is going to equal to 14 over 7.8. So that means x is going to equal to 3 ln 14 over 7.8 divided by ln 5. Now, let's say that we have ln 6x minus 1 plus ln x is equal to 1/2 ln 4. Ln x times 6x minus 1, that's going to equal to ln 2. This is going to be 6x squared minus x minus 2 is equal to 0. Therefore, x after factoring is going to equal to 2 over 3. Now let's say we have 3 to the power of 2x plus 3 to the x minus 2 is equal to 0. And let's do some u sub and let u equal to 3 to the x. So then we have u squared plus u minus 2 is equal to 0. Therefore we have u is equal to 1 and x is equal to 0. Now let's say we have 2 to the power of x plus 1 is equal to 5 minus 5 to the power of 1 minus 2x. X plus 1 times ln of 2 is equal to 1 minus 2x times ln 5. So x is just going to equal to ln 5 minus ln 2 over ln 2 plus 2 ln 5. That's it for this video.